Hi dear students. So in the last class we have discussed about Ohm's law. That is at a constant temperature, the potential difference across the terminals of a conductor will be directly proportional to the current which is passing through that conductor. That is V proportional to I, and there the proportionality constant value is known as resistance R. V is equal to R into I. So R is equal to V by I. That is the Ohm's law. We have discussed that one. And afterwards we have seen the factors which are affecting the resistance. We have seen that the length, area and the nature of the material. These are the major factors which are affecting the resistance value, where length is directly proportional to the resistance, whereas the area, cross-sectional area of the conductor is inversely proportional to the resistance, or resistance is inversely proportional to the cross-sectional area of the conductor. And afterwards we have seen a new term, that is the resistivity. Actually resistivity rho, it will be defined or represented in terms of rho. So rho is equal to R into A by L. That was also we have seen, and I would like to add up two more points along with that one. Okay, the resistivity of an alloy. Alloy means actually the combination of two or three metals. Okay, pure metals, we are just combining the pure metals, and that combination is known as alloy, and their physical or chemical qualities will be increased. We can increase the physical and chemical quality of the metals by combining them together. That are known as the alloys. So the resistivity of an alloy is generally higher than that of its constituent metals. So the resistivity of the alloy will be very higher compared to the resistivity of the metals which we are using to form that alloy. And one more benefit is there for alloys, that is alloys do not oxidize readily at high temperature. So it can sustain high temperature also. It will not burn or oxidize at high temperature. Due to this reason, they are commonly used in electrical heating devices like electrical iron, toasters and all. Okay, so the alloys are used in the electrical heating devices because its resistivity is high, or resistivity is higher compared to the metals, constituent metals, and they can sustain even in high temperature. That means they will not oxidize even at high temperatures. So due to this reason, they are used in electrical heaters or electrical heating devices. Okay, as well one another alloy, that is the tungsten. Tungsten is used almost exclusively for filaments of the electrical bulb. Say if you have seen the 100-volt incandescent lamps, in that one the tungsten filament is there. Okay, the resistivity of the tungsten filament is very high, so it will easily heated up, and the generation of the light energy then happen. Okay, the current energy in the tungsten filament, the current energy is converted into heat energy and light energy. Okay, so the main reason is that the resistivity of the tungsten filament is higher. And one more thing you have to add up along with that one, that means the even at high temperature the tungsten filament will not be oxidized. So that is the reason why the tungsten filaments are used in the incandescent lamp, or used as filaments in incandescent lamps. But at that time the copper and aluminium, their resistivity is very less, up to the range of 10 to the power minus 8. So that is the reason why the aluminium and copper wires are used in electrical transmission lines. The aluminium is used in the normal electric lines, isn't it? Electric lines, the aluminium wires are using as well in the house wiring, or the wiring that we are doing inside the houses. We are using the copper wires. Okay, the copper wires are little bit costly compared to the aluminium wires. That's why in the common electrical lines we are using the aluminium wires, but inside the house, for the wiring inside the house, we are using the copper wires. Copper wire is more having less resistivity compared to the aluminium wire, so it can conduct electricity efficiently as compared to the aluminium wires. Okay, now let us come to the example questions. Okay, so 12.3 we have already discussed. Come to the 12.4. The question is that the potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. So what current will the heater draw if the potential difference is increased to 120 volt? Okay, so two conditions are there. The first one is the potential difference between the terminals is 60 volt, and the second one, the potential difference between the terminals is become the double of that of the first case, that is 120 volt. So in the first case the current value is given 4 ampere. You have to find out the current value in the second case, where you know that the resistance is remain constant. So with the values of V and I of the first case, you can find out the value of resistance. So in the first case, the V1, let us take V1, which is equal to 60 volt, and the I1 is equal to 4 ampere. Okay, so R1 is equal to V1 by I1, so which is equal to 60 divided by 4, and that value will be is equal to 15 ohm. Okay, 15 ohm. So the next case, the V value is increased to 120 volt, where the resistance value will remain changed, that is R1 is equal to R2 is equal to 15 ohm. Okay, R1 is equal to R2 is equal to 15 ohm, and the V2 value is equal to 120 volt. You have to find out the value of I in this case. So I will be is equal to, or I2 will be is equal to V2 divided by R2. You know that R is equal to V by I, so I will be is equal to V by R. Here we are considering the second condition, so we have named the potential as V2, resistance is R2, and current as I2. So substituting the values, we will get I2 is equal to V2 by R2, that is I2 is equal to 120 divided by 15. 120 volt divided by 15 ohm. So that will be is equal to 8 amperes. Okay. So in that questions, two conditions given. The first it was 60 volt and the second it was 120 volt. For the first condition, the current value was 4 ampere. So using the current value and the potential value of the first case, you have found the resistance of that conductor. Okay. Sorry, here it is given as a heater. So heater. So the resistance of the heater you have found, and now we are increasing the voltage value to 120 volt. So you can use the resistance value of the heater over there, and the potential value it is 120, and by using these two values you can find the current which is passing through that heater during the potential difference between the terminals is 120 volt. Okay, so now let us come to the next question, that is 12.5. Resistance of a metal wire of length length 1 meter is 26 ohm at 20 degree Celsius. So R value you are having and L value also you are having. If the diameter of the wire is 0.3 mm, so diameter is given, so you have to find out the radius, isn't it? Then only you can find the value of the cross-sectional area of that wire. So diameter is given as 0.3 mm. What will be the resistivity of the metal at the temperature? At this temperature, means 20 degrees Celsius, at a constant temperature. Okay, you have to find out the resistivity of that material. So you know that rho is equal to R into A by L. R into A by L. This is the equation. So here R and L values are directly given. A value you have to find, isn't it? A value you have to find. Here you can find the A value as pi R square, but here it was given as pi D square by 4. That means pi into D by 2 the whole square. D by 2 means R and whole square means R square. So D square divided by 2 square. The 2 square will become 4, isn't it? So in such a way, in your textbook that is given. Okay. So then the equation will be R into, that is capital R is the resistance value, R into pi D square by 4 is the area of cross section, and divided by L. Okay. So in such a way it is given. So substituting the values, you have to substitute the values. So R is 26, rho is equal to R is equal to 26 into pi will be is equal to 3.14, 3.14. Okay, it's actually point only 3.14. Let it be pi. Now r square, that is d by 2 the whole square. So d by 2 whole square will be is equal to 0.3 is a d value. 0.3 mm is the d value. So you have to convert that into meter. That will be is equal to 3 into 10 to the power minus 4 meter. So when you are that is the d value. If you want to find out the r value, that divided by 2 you have to do, that is 3 into 10 raised to minus 4 divided by 2 the whole square, all divided by the length value, that is here L is equal to 1 meter. So you don't want to write that one, because the value divided by 1 will be that value only. Okay, so all divided by 1. Now you have to substitute the value. Already we have substituted. You have to just do the calculation. The pi value you have to substitute. Okay, 3.14. So just try that calculation. Okay, then the final value should be 1.84 into 10 raised to minus 6 ohm meter. Ohm meter is the unit of resistivity. And the second part of the question, in the second part of the question, it is asked to find out the metallic wire by which this material is made using the help of the value of resistivity. So you just turn your page and take the table number 12.2. So there the resistivity values are given. So here we have obtained the value as 1.84 into 10 to the power minus 6 meter. So ohm meter. Okay, 1.84 into 10 to the power minus 6. 1.84 into 10 to the power minus 6. So here, if you are checking the resistivity value of the manganese, okay, the manganese is having the resistivity value as 1.84 into 10 to the power minus 6 ohm meter. So the metallic wire with which that, okay, the metallic wire that we have taken is actually the manganese, as the raw value is equal to 1.84 into 10 to the power minus 6. Okay, so I think it is clear for you. Now come to the next question, that is (12.6). A wire of given material having a length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of the another wire of the same material having length L by 2 and area of cross section 2A? So in this case we are just having the length of a wire, and you have to find out the value of resistance, and the wire will be remain same. That means the resistivity value is same only, the cross sectional area is also same. Just want to find the change in resistance value when the length changed. So you know that length is directly proportional to the resistance, or resistance value is directly proportional to the length value. Okay, now let us see. You know that R is equal to rho into L divided by A. If you are taking the first case, R1 is equal to rho 1, and rho and A are same only. So L1 L1 rho into L1 divided by A, we can take like that. But in the case of R2 is equal to, the length is okay, length as well, the area is also changing. Okay, the same material having length L by 2 and area of cross section is 2A. So A1 also you have to take. Okay, so that means length and the area both are changing, only the rho value will remain the same, constant. Okay, remain constant. Okay, so R2 will be is equal to rho into L2 divided by A2. But here it is given that the length value of the second wire is half, okay, of the first one, that is L2 is equal to L1 divided by 2. So L1 divided by 2 all divided by A is increased or doubled value, area is doubled or double times that of that first wire. The area of the second wire is double times that of the first one, so it will be 2A1. okay, so R2 is equal to rho into L2 by A2, where L2 is equal to L1 by 2 and A2 is equal to 2A1. Now we have to do the calculation, so it will be is equal to, or we have to reduce the steps, then it will be is equal to, okay, I will write over here, rho into L1 divided by A1 or 4 times, that is 2 by 2 will be 4A1. okay, that is 1 by 4 rho into L1 by A1. You can see rho into L1 by A1 is equal to R1. So you can write this one as R2 is equal to 1 by 4 R1. okay, 1 by 4 R1. So R2 will be is equal to 1 by 4 times of R1. So R1 value is given in the question, that is 4 ohm. So if you are substituting the R1 value over here, that is R2 is equal to 1 by 4 times that of R1, where R1 is equal to 4 ohm, then 4 will be cancel each other, and the remaining, that is R2 will be is equal to 1 ohm. okay, 1 ohm. Is it clear? So that means we are decreased the length to the half of the first one and increased the cross sectional area or by double 2 times of the first case. But the material with which that wire is formed in both cases are same, that is the raw value will remain same. okay, then we are using the relation R is equal to rho into L by A. In the first case R1 will be is equal to rho into L1 by A1, but in the second case R2 will be is equal to rho into L2 by A2, where L2 is equal to L1 by 2 and A2 is equal to 2A1. So we have changed the L2 into the term of L1 and A2 into the term of A1. So by substituting the values, then if you are doing the calculation, you will get the R2 is equal to rho into L1 divided by 4A1, that is 1 by 4 times R1. So R2 is equal to 1 by 4 times R1. So R1, the value of R1 is already given in the question as 4 ohm. So substituting that value, so 1 by 4 into 4 ohm, that will be the value of R2, and 4 will be cancel each other and the remaining will be 1 ohm. So R2 value will be is equal to 1 ohm. okay, so I think this much things are clear. Now we will discuss that index questions also. On what factors does the resistance of a conductor depend? So we have in the theory section we have studied that one. It is the resistance of a conductor mainly depends on its length and its area, as well the material with which that a conductor is made. So these are the three major factors on which the resistance of a conductor is depending, where R directly proportional to the length and inversely proportional to the area. Okay, that one is cross sectional area. That one also you have to add. Now the second question is that will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? So the same material means rho is same source means V is also same, only the value that you have to consider is the change in the cross sectional area. That means a thick wire will be having more cross sectional area and the thin wire will be having less cross sectional area. So the resistance value will be, if you are measuring the resistance value is inversely proportional to the cross sectional area. That means if the cross sectional area is increasing, then the resistance value will decrease. Okay, so in this case R proportional to 1 by A. So thick wire will be having less resistance compared to the thin wire. So the current will easily flow through the thick wire, okay, as we compare to a thin wire of the same length and of the same material. So the current will easily flow through the thick wire. For the thick wire, the resistance value will be less. Now let us come to the third question. Let the resistance of an electrical component remain constant while the potential difference across the two ends of the component decreases to half of its former value. What change will occur in the current through it? Okay, so R is equal to V divided by I. Here R will be remain constant. We are just changing the V as V by 2, isn't it? V remain V by 2. So R dash, let us the second case we can consider the R dash as R dash will be R will be remain constant. Okay, we have to find out the I value. Okay, so let's take in the second case also R is equal to V divided by 2 by I dash. We have to find out the I dash value. So I dash value will be is equal to, implies I dash is equal to V by 2 divided by R, isn't it? R remain constant. So we have to substitute the R value, that is a V by I. So implies, I am writing here, implies I dash is equal to V by 2 divided by V by I. Okay, so V cancel and I will go to the numerator. So I dash will be is equal to I divided by 2. So in this question, if in the case of a conductor, if the value of the resistance remain same and the V become the half of the first case, then the current which is passing through the conductor will become half compared to the first case. So that means if V changes to V by 2, then I will change to I by 2 if the resistance of the conductor remain same. If you are keeping the resistance of the conductor same, constant, then V become V by 2 means I should become I by 2. That means V directly proportional to I. You have to remember that relation, that is Ohm's law. Okay. Now the next question, why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? For this question, the answer we have discussed in the beginning of the today's section. We have already discussed the answer, that is the resistivity of the alloys will be more, and as well it will not get easily oxidized even at high temperatures. That means even if at high temperature it will not burn. So that's why the alloys are used, or alloys are using in the case of electrical heaters. Now the next one, that is the use the data of table number 12.2 to answer the following. So you just take the table number 12.2. The first one is that which among iron and mercury is a better conductor? In the case of iron, the resistivity value is 10.0 into 10 to the power minus 8. But at that time, if you are comparing the mercury, the value is 94.0 into 10 to the power minus 8. So the resistivity value is higher for the mercury. So as per our question, which among the iron or mercury is better conductor? So mercury is having higher resistivity. So compared to that of iron, the mercury's conductivity will be less. So the better conductor will be iron. Iron is the better conductor because iron is having less resistivity compared to that of mercury. Okay. The next question is that which material is the best conductor? All over the compared to the all over the materials given in the table, which one is having the, or which one is the best conductor? So you can say, comparing the resistivity values, the silver is having the least value of resistivity, 1.60 into 10 to the power minus 8. So as per the table number 12.2, the silver will be the best conductor. That means whenever the resistivity value is decreasing, the conductivity or the ability to conduct the electricity will increase. So if you want to find the good resistor, you have to go for the higher resistivity value. If you want to find out the good conductor, you have to go for the least value of resistivity. Okay. So is this much clear? So in the coming class, we will discuss the resistance of a system of resistors. Okay. So it is a series resistance, parallel resistance, and their derivation, equivalent resistance, the derivation, all those things are there. So actually that is very interesting topic. So just study these much things before we are going to the resistance of the system of resistors, and as well before the next class you just read that portion. Okay, so you will get a rough idea about that one. So whenever we are discussing, it will be more easy to understand then, and as well you will have doubts. If you are preparing before I'm teaching you, you will have some more doubts. Your own doubts will be there. Okay. So wish you all the best. Thank you.